Good day, everyone. So this is going to be theorem number 3. It's not that hectic. I think every theorem has a similar process on how to prove or how to determine certain things. So it's just a link of everything that I've done. It's a repetition. It's nothing new, and this is a figure that you're mostly well known of. So theorem number 3, it's basically about the right angle triangle, right? But what is special is that with only the effect of a line, it can produce triangles that are similar, right? But which are of the same figure. Now, the definition states that a line drawn from the vertex, remember your vertex is going to be point A, so vertex is going to be your top point, and the vertex at the right angle, so there's going to be the right angle of a right angle triangle, right? So right angle triangle of A, B, and C. Then it says perpendicular to the hypotenuse side. So remember, your hypotenuse side is opposite to the 90-degree angle, right? So meaning that the line that is drawn from your vertex perpendicular to your hypotenuse side, right, divides the triangle into two triangles, meaning the triangle A, B, and C is divided into two triangles which are similar to each other and also to the original, meaning that triangle number 1, number 2, and number 3, they are similar, right? Now, what is special about this is that we use symbols which will guide us on how to put our triangles into order. Remember that when you're dealing with similarity, we have to make sure that the order is in place, right? So now it states that each triangle has 90, then you have a closed dot and a cross multiplication sign, sorry. So it's going to be a multiplication sign. So meaning that your dot and multiplication sign, they sum up to 90, right? For example, this is going to be triangle ABC. Angle A is 90, meaning that the sum of B and C, which is your dot and your X, they're going to be 90 degrees, right? So now I'm just going to explain this figure like into detail so that you can understand what is happening as to how did we come about ABC similar to PBA, similar to PAC, right? Now, the reason, especially for theorem number 3, is going to be a line from right angle. So this is going to be the line from right angle vertex, right? So line from right angle, then it's going to be vertex, it's going to be perpendicular to what? To hypotenuse. So it's going to be line from right angle vertex perpendicular to hypotenuse. So whenever you have to write the reason based on the similarity of this 3 triangles or maybe 2 concerning your right angle triangle, then that's going to be the reason, right? So now I'm just going to explain this into detail so you can understand on the construction and the labeling and the order of your angles for those 3 triangles. So this is your basic triangle of ABC. So this is triangle A, B, and C. So now for the given triangle, we're gonna plot 2 symbols for these 2 given angles of B and C. So for C, I'm gonna use X. So for C, you're just going to use X. Then already you know that for 90 degrees, for A, it's going to be 90. Then you're going to use this symbol of 90 degrees. Then for B, you're going to use a closed dot. So meaning that for B, you're going to use a closed dot. So meaning that the order of your angles for each and every triangle is going to be your angle, closed dot, and X, right? If you can check, X is on the longest side, then your closed dot is going to be on the shortest side. So now the theorem says that a line drawn from the vertex, so meaning that we have original right angle triangle of A, B, and C. Now if you draw a line from the vertex of a right angle triangle that is perpendicular to a hypotenuse side, meaning that if this line is perpendicular, so meaning that we're going to have 90, then we're going to have 90. So meaning that we have 2 90-degree angles. So this is going to be angle number 1, and this is going to be angle number 2. So now we're gonna name this angle P, right? So now it means that out of one right angle triangle, when we divide into 2, it means that we're gonna have 3 triangles, right? So now this is how you work with order of triangles, right? So now remember, we're starting with your angle of A, then we go to B, which is a closed dot, and we go to C, which is your X. Now let's look at the given 2. Remember, so this triangle is going to be this one. So let's look at the triangle of this part, right? So meaning that you're starting with angle. So the first 90 degrees, remember, starting with 90 degrees, same applies to this one. The first angle is going to be 90. So with this one, we know that the angle is going to be what? It's going to be P, right? Then we said the closed dot, where is going to be the closed dot? The closed dot is going to be where? At B. Remember, for AB, the shortest side is going to be your dot. For this side, the shortest distance is going to be what? B as well. So it's going to be B. So B is going to be your closed dot. Then A, so what is going to be A? So A is going to be the longest side, right? So meaning that A is going to be your longest side, which is the hypotenuse side. So A is going to be X. So it's also similar to triangle. So this is going to be the second triangle. So this is going to be the third. So we say that angle 90, we're starting with angle 90. Angle 90 is going to be P as well. So which is 90. Then we go for closed dot. Closed dot is going to be the shortest distance. Remember, the shortest. For triangle, for this triangle, the shortest is going to be PA. So it's going to be A, then with what? C, followed by C. So C is going to be X, right? So meaning that you can see that it's going to be angle closed dot X, angle closed dot X in your 90 degree angle closed dot X. So meaning that this is going to be the order, because now if you don't do things in this way, then it's going to be a problem for you. Because now if you can identify the following, the triangles that we have is going to be this one of PEG, PAC, and the other one that we're going to have is going to be PBA, and the overall original is going to be ABC, which is this one. Right. So this is going to be triangle number 1, number 2, and number 3. Right. So now we're going to do example 21 on page 259. So example 21 says, in the sketch aside, which is this one, triangle ABC is a right angle triangle with AB, with B with an angle of 90. Then line BP is drawn such a way that BP is perpendicular to AC, right? Remember, this is the line that is drawn from the vertex perpendicular to the hypotenuse side. So if this is 90, this is also going to be 90, right? Remember the order that I've told you, that you start with your 90, your closed dot, and your X. You're going to apply this rule for this one as well, so that you can be able to solve this question. So we have to prove that AB to the power squared is equal to the product of AP and AC. Then number 2, we have to prove that BC squared is equal to the product of BC multiplied by AC. And also we have to use the results of A, which are these two, that we're going to find out that AB squared plus BC squared. So meaning that AB squared, we know that it's AP multiplied by AC, plus BC squared is equal to this one, PC multiplied by AC. So that when we solve, we must be able to get what? AC squared at the end, right? So now there's going to be a figure of ABC, and right. So now out of this, we have to abstract all the three triangles from the given figure. So now remember that the rule is to start with your 90. So now let's look at the following. So now first triangle is going to be triangle ABC, right? So this is going to be triangle A, B, and C, right? If you can check, it's up to you, right? We know that B is going to be 90. Then you're just going to add a symbol of 90. Then you're going to start with A. It's either you choose A to be X or an open dot. It's up to you. So the shortest distance from the previous example that I did is to use this as your open dot. And so this is going to be an open dot. Then C is going to be X. Then C is going to be X. So now we have to follow this order. It's going to be a closed dot, right angle of 90 degrees. Then it's going to be your X. Right, so meaning that this is going to be for your overall triangle of ABC, right? So that's going to be for your overall triangle of ABC. Now let's look at triangle. So let's look at this triangle. This triangle. Right. Remember that we say that your open dot is going to be your shortest distance. So now meaning that for this triangle, you have 90 degrees, which is P, right? Then your shortest distance, first you remember we're starting with a closed dot, which is A. So, but for this triangle, it's going to be B, right? Remember that from 90 degrees to B is the shortest distance. Then from angle B to A is also a short distance. That's why I'm using the open dot. Then you're going to use X. So X is going to be X, which is C, right? So it's a given to us. So if you have to write this one, it's going to be B, then it's going to be 90 degrees, it's P, then it's going to be C, which is this one, which is an X. So meaning that it's going to be closed dot, 90 degrees, then is X. Then we go to the third triangle, which is this one. Right. Now, already have a closed dot here, which is A for this triangle. So it's 90 degrees to closed dot. So meaning that it's going to be triangle. So you're starting from what? Starting from A. Then what is going to be 90 degrees is going to be P. Then your longest distance is going to be X. So this is going to be X. So this is going to be B. So now you have 90 degrees, you have X, then you have closed dot. So these are the three triangles that you have, right? Meaning that for each and every question that is given to you here, you have to check which two triangles you're going to use. Because now if you can check, here it says that prove that AB squared is equals to a product of AP and AC, right? So now we have to choose which triangles have these proportional sides. So we have AC, we have AP, then we have AB. What don't we have here? We don't have what? PB. We don't have PB at all, right? I mean, we do have PB, but we don't have PC. Sorry for that. So we have AB. This triangle has AB, AC, AC. So this one is going to qualify. Then we look at the second one. The second one doesn't have AB. It doesn't have AP, and also it doesn't have AC. So this one, it's not going to work. But looking at APB, AB, we do have AB, AP, we do have AP, AC, we don't have AC, but it's also fine. It's not a big deal. What matters is that all of these, at least a pair, right, should be given. So meaning that if you have to solve number one, so number one, you're going to work with these two triangles. So meaning that you have triangle ABC, which is similar to triangle APB, and you have to give your reason. Your reason, I don't have space. Let me just write it. So you just have to write it on your right hand side. So it's going to be line from right angle vertex perpendicular hypotenuse. Right, that is going to be your reason, right? So now remember that if they ask you to prove, this is basically the sides which are corresponding sides which are proportional, right? In this form, the first step is to ensure that before you prove that these are proportional, you have to first make sure that you identify the two triangles. Then from there, determine the proportional sides. Then from there, you have to choose which two appear from these. Then from there, you can be able to solve, right? So now let's start with the first one. So now it's going to be AB and AP, right? So it's going to be, right, this way. So it's going to be AB over AP, then PC and PB. So it's going to be BC and PB. Then we have the last one, which is this one. So it's going to be AC and AB, AC and AB. Now the reason is going to be similar triangles. So there are similar triangles. But now let's look at the question. We have AB, AP, and AC. AB, AP, AB, AP, then have AC and AB, meaning that this one is not going to work for us. So that means you're going to exclude this one because we are working with AB, AP, and AC. AB, AP, AC, AB. So BC, PB, it's not part of the given form. So we were going to use only these two. Therefore, we have AB over AP is equals to AC over AB. Then when you cross multiply, you're going to have AP squared is equals to AP multiplied by AC. Sorry about this, multiplied by AC. So that is how you solve this type of problem, right? So remember, step number one, you have to identify through the given diagram to have your three triangles. Make sure that the order of your angles are 100% correct, because when you're dealing with this type of questions, order is very important. So after establishing your triangles, you have to check out of these three, which one do they satisfy the given problem to solve. Then from there, you have to identify those two triangles. Then after having to identify, you write the proportional sides, and your reason has to be similar triangles because we're dealing with similarity here. Then out of these three, you have to choose that is going to satisfy the given problem. Then from there, just cross multiply, then you get your form, right? Remember, the only way is to establish your triangles first. You cannot solve this type of question if you haven't identified the problems, right? So let's go to number 2. All right, for number 2, it says that you have to prove that BC squared is equals to PC multiplied by AC. So it's a product of PC and AC, right? So now we have to check from these three triangles which of the two satisfies the following, right? So now we have BC for the first triangle. We have BC, okay, BC. We do have PC and AC. We do have AC at least, right? So we have two sides. Then we have the second one, which is BC, right? We do have BC. PC, we do have PC. Then AC is fine, doesn't matter as long as we have two sides. Then the third one with AP, there's no AP. Then PB, we don't have any PB. AP, we don't have. So meaning that we have to choose only these two. So meaning that for number 2, we're going to choose triangle ABC. Then we have triangle BPC. Then your reason, so your reason is going to be this one. Please write for this part, your reason is going to be line from right angle vertex perpendicular to hypotenuse. This is going to be your reason, right? Remember, this is your statement, this is going to be your reason. Then now from there we just have to choose. So we have BP, we have AB over BP, then we have BC over PC, then we have, lastly, we're going to have AC and BC. AC over BC. Now looking at the following expression, AB and BP, we don't have any AB, we don't have any BP, so meaning that this one is going to be excluded. We're not going to work with it, right? Now only two that you're going to work with is going to be these two. Remember, after writing this is going to be similar triangles, right? Then from there you're going to have, therefore we're going to have BC over PC, then you're going to have AC over BC. Then when you cross multiply, you're going to have BC squared is equals to PC multiplied by AC, right? So that is going to be your answer for number 2. Now B states that use the results from A to prove that, so this was A, sorry, this was A. So we have to prove that AB squared plus BC squared is equals to AC squared using the results from A. So meaning that the answers from A, we have to use them in order to solve this problem, right? So now if we can check AB squared, BC squared. So now what is AB squared is equals to? We know that AB squared is equals to AP multiplied by AC plus, then what is BC squared equals to? BC squared is equals to PC multiplied by AC, right? Now from there, what we notice that we have a highest common factor, which is AC, right? We have AC, then we have what? We're left with what? With AP plus PC, right? Now looking at your diagram, what is AP plus PC? Looking at this diagram, what is AP plus PC is equals to? Because we have a sum of AP and PC, meaning that these two line segments, they have a total line segment of what? Of AC, meaning that AP and PC is a total length of what? Of AC. So meaning that here AP plus PC is equals to what? Is equals to AC, which is equals to what? Which is equals to AC squared. So we have proven that AB squared plus BC squared is equals to AC squared.